So what is inner product space? Let U, V, and W be vectors in a vector space V. Then inner product space of two vectors U comma V, which can be represented in this bracket, and this is known as inner product space. So this U, V, W, if these three are the vectors in vector space, and then we can form these are the inner product space if they will satisfy following properties. First property is what? Inner product space of U comma V. This must be equal to inner product space of V comma U. Second property, inner product space of U comma V plus W. This must be equal to inner product space of U comma V plus inner product space of U comma W. Third property, if I am multiplying C, where C is a scalar, if I am multiplying C in the first component in U, so inner product space of C U comma V, this is defined as C times inner product space of U comma V. And last property, of inner product space is inner product space of V comma V or U comma V. This will be always greater or equal to 0, and inner product space of V comma V, this can be 0 if and only if this V equal to 0. So if any space which will satisfy these following properties, we can call inner product space. So let me explain some example. And standard inner product space of two vectors is defined as, for example, if I am writing here U equal to U1, U2, comma U3, and V equal to V1, comma V2, comma V3. If U and V, these two vectors, which is belonging in R cube, this is V is also belonging to R cube. So what will be the standard inner product space of U comma V? So this is defined as, already we know that dot product of two vectors. So this you can write U1 into V1 plus U2 into V2 plus U3 into V3. So this is called standard inner product space. If I am asking what will be length of U, so length of U in inner product space, this is defined as norm, and norm we are writing by double mod. So this is defined as under root of U1 square plus U2 square plus U3 square. So you are looking this norm of U, this would be always greater or equal to 0 because this is length. So this length actually norm U we are calculating with respect to origin 0, 0, 0. Similarly, if I have to calculate norm of U minus V, what will be length of U minus V? So this also we can calculate as we have calculated distance between 2 points. So this we can write U1 minus V1 whole square plus U2 minus V2 whole square plus U3 minus V3 whole square. So this is the concept by using which I can calculate norm of U and norm of U minus V. And also we have studied how to calculate angle between two vectors. This is also we are knowing. If you are having this vector U equal to same vector, then what will be cos theta? Cos theta we have studied U1 V1 plus U2 V2 plus U3 and V3 and divided by mod U and mod V. So this we have studied in vector calculus, but same definition we can generalize in inner product space. So this will be cos theta equal to this U1 V1 plus U2 V2 plus U3 V3. This is nothing but standard inner product space of U comma V. And because as I told, norm this mod U is represented in inner product space as a norm U. So this is norm U and this is norm V. So this is the way to calculate inner product space of U and V, and angle also we can calculate. And also norm of U also we can define as under root of inner product space of U comma U. This is also important result. How we can how we are getting this one? If you will observe here, U1 is norm U is UN square plus U2 square plus U3 square. So what we are doing, we are just taking inner product space of U with U. Then only you will get U1 square plus U2 square plus U3 square. And because we are getting here under root, so norm of U, we can write inner product space of U comma U, and this is in under root. If you will make square, then you will get norm of U whole square equal to norm of U into U. Next, if suppose we are having some example and we have to prove that these are inner product space or not inner product space, then how we can satisfy the given four properties. For example, we are having one example. Suppose if inner product space of X and Y, this is given as X1, Y1 plus X2, Y2, and we have taken vector space V equal to set of real number R2 space. So X we can consider in this space X equal to what? Because we are considering R2 space. So this is given to us inner product space of X comma Y. This is equal to X1 Y1 plus X2 Y2. So now if this is inner product space, then it has to be satisfy the given four properties, where X is what? X equal to this X is because this X and Y we are choosing from R2 space. So X we can take X1 comma X2, and Y we can take Y1 comma Y2. So what will be inner product space of? So according to first property of inner product space of X and Y, this must be equal to inner product space of Y comma X. So what will be inner product space of X and Y if X is X1, X2 and Y is Y1, Y2? So we can apply the concept of standard inner product space, which is defined as first component into first component. So we can get X1, Y1. So this equal to, just 1 minute. So this equal to inner product space of X and Y. We can write X1, Y1 plus X2, Y2. And what will be inner product space of Y and X? This is also equal to Y1, X1 plus Y2, X2. So simply you can see these two are equal. So this will satisfy first property. Now what is second property? Second property is what? Because in second property we need three vectors. So let us assume that this is A. A is first property. I am giving name A. So A is satisfied. So for B, let us assume that Z equal to what? Z1 comma Z2. So according to third property, X comma Y plus Z, inner product space of X, Y plus Z, this must be equal to inner product space of X and Y plus inner product space of Y and Z. So left hand side we can equate to right hand side. So what will be inner product space of X and Y? This is simple X1 Y1 plus X2 Y2. And what will be inner product space of Y and Z? So Y1 Z1 plus Y2 Z2. And left hand side X, inner product space of X and Y plus Z. So this we can write what is X? X1 comma X2 comma Y plus Z is what? We can add Y and Z. So y plus z we can get because I hope you are knowing component wise addition. So if you have to add y plus z, so this we can get y1 plus z1 comma y2 plus z2. So what will be inner product space of these two? So left hand side we can get x1 y1 plus x1 z1, this equal to 1 second. This actually I have written wrong. Inner product space of x, y plus z is equal to inner product space of x, y and x, z, not y, z. So inner product space of x, y plus z, this must be equal to inner product space of x to y plus inner product space of x to z, not y to z. So what will be this left hand side? Left hand side, because x vector we have taken x1 comma x2. So you can write x1 comma x2 comma y plus z. Y plus z will be what? Component wise addition you can apply. So in bracket y1 plus z1 comma y2 plus z2. So what? How you will calculate inner product space of this one? So first component here is it must be multiplied with first component. The second component will be multiplied with second component. So what we can get? X1 multiplied with y1 plus z1. So we can get x1 y1 plus x1 z1 plus second component multiplied with second component. So you will get x2 y2 plus x2 z2. So this is left hand side. Now right hand side, how you can calculate net product space of x, y and x, z? So RHS will imply inner product space of x and y. Again, we can apply standard inner product space, which is given by x1 y1 plus x2 y2 and inner product space of x and z. So x1 z1 plus x2 z2. So we can observe here. This is if I will LHS if I will consider equation first and RHS if I will consider equation second. So both are equal. So second property also satisfied. Now third property is what? Third property, I am giving name here. See, if I am multiplying with scalar in the first component, inner product space of C into U or C into X, because we have given X here, so we can write here X. So inner product space of C and X comma Y, this must be equal to C times inner product space of X and Y. So again, we can calculate left hand side and right hand side. So inner product space of C and Cx and Y will be what? This we can write. You multiplied because X we have taken x1 comma x2. So you multiply by C. So we can get C x1 plus Cx1 comma Cx2. Right, because X is what? X2 if you by C, you can get Cx1 x2 bracket. Y is what? Y1. What will be in a standard in a first component multiplied with first, so you will get Cx1 y1 plus Cx precisely for space of x and y C. So you write here C, and inner product space of x and y is what? Also equal into property 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 giving here According to fourth property, x and x is greater or equal to 0 because length of a vector is always greater or equal to 0. And if it is 0, if it is 0, x is 0. Because we know that length. What will be inner product space of x and x? So this you we can write it because and x is also x1 x2 multiply and get x1 is plus x2 is x and write inner again comma x2. What will be inner product space of these two are same. X1 multiplied with x1, x1 is square, x2 multiplied here. So obviously this as both are positive, it's always greater or equal to 0. And if it is 0, I am writing x1 is square plus x2 is this is x1 is if because sum of two positive numbers x1 is square is also positive, x2 square is sum of two x1 is 0, x2 0, both are 0, then x equal to this of x and x always greater. So then x has to be property of we can say that the given is I will change slightly. So this is defined as x1 y1. The first case, if that plus if I will replace by minus, then what will happen? You can find out. So x1 y1 minus x2 y2. If I will calculate now, I am going to property number 4. The product space of x and x will be x1 is square minus x. According to the property of this must be greater or equal to 0. If I will choose, I am choosing x1 x2. Obviously, we can choose because because this x is random vector of R2. So what will be x1 is square 1? What will be x2 is square minus this quantity greater than I am choosing x inner xy by x. 4 is failed. X and x and regard problem times if we are asked to calculate are having x equal angle between x and y is can calculate cos theta divided by this. Obviously we can x and y will be what component with first plus 4 8. So this 9 divided by 1 square plus x2 square, so 1 plus 4, and norm of x2 square is 2 square 4. This like that we can calculate. Sometimes if we are having the given vector, so easily we can calculate. But if we are having kind of inner product vector view x these two are the subspace of P2. P2 means what? Set of all two polynomials. Structure of P2 can say like P2 is equivalent. If V1 are choosing space of P2, I have to calculate and calculate what is angle between U and V. Angle calculate time have to apply standard and how we calculate what will be this space in this text. If I am asking you what will be the coefficient of x, what is coefficient of x, what is coefficient of constant, x square is given, what will be coefficient of x coefficient of constant. We are having some functions are given like x square, x cube, whatever. Also, so what will be coefficient of x is given here 1, coefficient of x square is 0, and coefficient of constant is also. Now we are having v1 and v2, so now easily we can calculate inner product space of v1 and v2. This will be what? 0 into 1, so we can get 0 plus 1 into 0, 0 plus 0 into 0, 0. So cos theta equal to inner product space of v1, v2 and divided by norm v1 into norm v2. So this easily we can get because numerator is 0 and divided by norm v1 is 1, norm v2 is also 1. So finally you will get 0. So theta will be what? 0. So like that we can calculate. Suppose in the same question, if I am giving here v1 equal to 1 and v2 equal to x, correct? And if inner product space of u and v is defined as 0 to 1, 0 to 1 u of x into v of x into dx. Suppose sometime inner product space is defined in this form, then how you are going to calculate angle between v1 and v2? So again we can apply what is cos theta, angle between two vector. We know that cos theta equal to inner product space of u comma v divided by norm norm v1 and norm v2. So cos theta equal to cos theta equal to what is formula? Inner product space of v1 comma v2 and divided by norm v1 into norm v2. So how to calculate norm v1 and v2? Because this time inner product space given in this form. So v1 is given 1. So what, and v2 is given 1. So what will be inner product space of 1 comma x? So this will be, because we are given inner product space in integral form, so we can apply 0 to 1. First function u of x is given 1. Second function is given x, so 1 into x into dx. integral of x, we know that x square by 2, and when you will put limit, so we can get 1 by 2. So this is inner product space of V1 and V2. Now, how you will calculate norm V1? This is important because we know that norm V1 comma V1, inner product space of V1 to V1. This will be what? Under root of inner this V1 is square. And how you will calculate inner product space of V1 and V1? This we can write norm norm V1 is defined as this norm V1. This is defined as under root of inner product space of V1 and V1. So how to calculate inner product space of V1 and V1? So this equal to under root of, because norm V1 this time inner product space is defined as in an integral form. So 0 to 1. V1 is also 1, V2 is also 1. So 1 into dx. So this equal to integral of 1. We know that x. And when you will put upper limit, so we can get 1. Similarly, we can calculate what is inner product space of V2. Sorry, what is norm of V2? So norm V2 is this equal to defined as under root of norm V2 inner product space of V2 and V2. So this equal to under root of 0 to 1. So V2 is given x and V2 is also x. So we can get x into x, x square into dx. Why? How we are getting x square? Because inner product space of u and v is defined as integral 0 to 1 u into v. So first function, if you will replace v by also u, so we can get x into x, x square, and x square integral x cube by 3. So final you will get, because this is given in under root 3, so you will get 1 by under root 3. So what will be cos theta? So cos theta equal to inner product space of u and v. And inner product space of u and v, we just now we calculated 1 by 2. So this equal to 1 by 2. And inner product is and norm of v1. Norm of v1 we have calculated 1, and norm of v2 we have calculated. So norm v1 1, and norm v2 is what? 1 by root 3. So this we can finalize, this equal to under root 3 by 2. So theta equal to, we know that under root 3 by 2 is what? Cos 30 degree. So theta we can get 30 degree. So if you are having some vectors are given, then it is easy to calculate. But if you are given some function, and if standard inner product space are given, then we can calculate vectors by comparing the coefficient of whatever polynomial given. And if some inner product space are given as, then we can calculate by using this concept. But one thing only you keep in mind, norm of V, this is defined as under root of inner product space of V and V. This formula is important and many times we have to use. So norm V is defined as V comma V. Similarly, you can find a distance between two function. If I am saying what will be the distance of x minus x square, so that also we can calculate by using this inner product space. So in next video, I will discuss about Graham-Smith orthogonalization process and what are the orthogonal vectors and what are the orthonormal vectors. Thanks for watching.